This video is for the worksheet that we've been working on, getting names and formulas and structures together for all of our ionic compounds. It does start with the understanding that you understand how to draw Lewis dot diagrams. It starts assuming you know why we're drawing these arrows to show the movement of electrons to fill a valence shell. It assumes that you know that metals form empty valence shells and makes cations, and it assumes that you know that anions are formed by nonmetals and that they're negatively charged, and we how to draw those. So what we're going to focus on here is how to come up with names and formulas, go back and forth, and how these guys relate to our structure. So if this part is where you're struggling, you'll need a different video or to come and see me separately. Okay, on your worksheet it tells you that this is the name. This is where we're going to draw the structure, which are these guys here. So that's what's going in, and over here is going to be the formula. So the three things that we're going to try and link up here go like that. Now, I'm starting with a name in this case, and so in this case it's lithium oxide. Hopefully everybody realizes that lithium is Li, and this would be just a sheet of paper that I'm scribbling on. And oxide, IDE, is the suffix we use for anion. So this actually right here is an oxide, which comes from oxygen. So I'm going to draw an oxygen here. Now, in order to do the Lewis dots, you know that lithium is group 1, so it has 1 dot. Oxygen is group 6, so it has 6.
Mr. Pierce and Mr. List, please call the office. Mr. Pierce and Mr. List.
And that's going to go over here and try to fill up this valence shell. Now, unfortunately, this is empty, so the only other option I have is to have another lithium, because I have an infinite number of atoms. Goes here. So that's what's going to happen. Now this, what I'm drawing, the end result is actually what goes in this box up here. So I had 2 lithiums here, so I'm going to end up with 2 lithiums over here, if I can fit them. But they're no longer lithium atoms. These are lithium ions. They've lost an electron, so I'm going to put brackets around them. We always use square brackets for this. And since I've lost a negative charge, I have more positive charged protons, and then I do negative charged electrons. So if I lost 1 electron, that means I have 1 extra positive on each of those. This oxygen had 6 originally, electrons, but now it has 8 electrons. So it's no longer oxygen, it's an anion. And since it gained 2 electrons, it has 2 extra negatives. So this would be what the structure is. This is what the ions would look like. And to write a formula, the formula just simply counts what's in this box here. So I have 2 lithiums. We would write that Li subscript 2 and 1 oxygen. O. In chemistry, we never write the ones, we just omit them. So that's how I would fill in a simple binary ionic compound. For example, we're given the formula here, which gives us more information than even the name did in the last one. There's a couple ways to go about this. We could go this way here and draw the ions, or we could just go right to a name. I'm going to move over because I think this gives me enough to draw the ions. K, if I look it up on my periodic table, is for potassium. And potassium is group 1. But this tells me there are 2 potassiums, so I'm not going to have to figure out how many there are. I know that there's 2 potassiums. And there's a sulfur right there, so there's only 1 sulfur. Sulfur is group 6. 1, 2, 3, 4, 5, 6. It's actually group 16, but it has 6 electrons. And look at this. We have 2 empty spaces and 2 potassiums. So it's very similar to our last example, except the formula tells me what's there. Now, if we understand ionic bonding, then we actually don't need to draw this out. Potassium, there are 2 of them. So I'm just going to draw them right here. And I know group 1 is always going to lose 1 electron. Always. Because they only have 1 in their valence shell. So I'm going to go straight here and say, well, it's going to lose it and become positive. And sulfur has 6 electrons in its outer shell. It's always going to have 8 electrons when we're finished because it's a nonmetal. It's an anion. Which means if it had 6, it's going to gain 2, and gaining 2 gives you a 2- charge. 2 minus charge. And so I can draw those directly from this formula without ever having to do this. Now you're welcome to draw this out, sketch it out on a piece of paper like I did, and you'll get this here. But you can, as you start to realize that those ions, you know what the ions are, it's on your periodic table, you can just use the formula to draw the number right there. And like I said, we found this, it was potassium, so that's be called potassium ion. We always drop the term ion whenever we're writing a name. So it's just potassium, and this is sulfur, but instead of writing sulfur, when it's an ion, we erase the name, we change the suffix, and we add I-D-E. So the name of this compound would be potassium sulfide. Sulfide means that it's an anion.